Unit 1, June 2017, Section A, Question 1. The diagram shows a mounting plate that is stamped from sheet aluminium, and we can see that diagram that it's referring to here. This is clearly in the shape of a sector, part of a circle, so here must be an arc and these are radii. Angle in the center is marked in degrees, pay attention to that, and the radius is given in millimeters. Let's see what they want us to do. Calculate the length of the curved side of the plate. The curved side, aka the arc. Okay, so we need to find the arc length. Referring to the formula sheet, we'll see that we can find the arc length by multiplying the radius by the angle at the center, but only when the angle is in radians and our angle is in degrees. So the first thing we need to do is to convert 66 degrees into radians. Although I'm going to do this in the calculator, I'm going to show my working out here so I can get the full marks. The conversion, you can either do it as 2 pi divided by 360 or pi divided by 180 because that's a simplified version. In the calculator, 66 times by pi over 180 gives me 1.1519, etc. 1.1519 is enough to be starting with. Now let's have a quick think. Is that realistic? I know just from my sort of rule of thumb that 1 radian is about 60 degrees. That's about 60 degrees. That's about 1. So I'm going to give this to 3 significant figures. Oh, no, I'm not. I haven't finished yet. This is just the angle at the center. So I'm going to leave that like this for now. I'm not going to round it because I'm going to use it in my next stage of working. And if you remember from earlier, the next stage of working is I need to multiply this angle in radians, which I've now got, by the radius. On my calculator, I'm not going to type that in again. I'm going to use the answer function because that's just now stored that there and times it by 52. Just double checking. Yes, it's 52 that I want. And that gives me 59.8996. Just write down my working out first. 1.1519 times by 52 equals 59.8996 and so on. And that means that the arc length will be 59.9 millimeters to 3 significant figures. Question 2. An automated electronic alarm is set to provide 2 warning beeps, and that matches the fact that they want 2 answers, during a CNC cutting cycle. The timing of the alarm is given by the equation 6t squared minus 16t plus 10 equals 0, where t represents the time in seconds. I'll underline the units so I don't forget to use them in my answer. Find by factorization, so only use the quadratic formula if you don't want any marks. Find 2 times, yeah, we've noted there's 2 of them, when the warning beeps sound. Okay, so I have to use factorization. I'm expecting 2 answers and my units will be in seconds. Let's have a look at this equation. Well, the first thing I'll note is it is already equal to 0. That's helpful. The next thing that I'm going to look at is, can I factorize the coefficients 6, negative 16 and 10? Well, they are all divisible by 2, so that will be the first thing that I'm going to do. 3t squared minus 8t plus 5 equals 0. And that's just made my life a little bit easier with smaller numbers to work with in the next part. Let's begin that now. So I'm going to have 3 times 5, that's the coefficient of the quadratic term and the constant, they give me 15. And I want 2 numbers that times to give 15 but add up to give minus 8. Well, I know that minus 3 times by minus 5 gives me positive 15. And I also know that minus 3 plus minus 5 gives me minus 8. If you're at all unsure about negative numbers, well, that's definitely something to revise, but as a stopgap measure, just stick those in the calculator and you can just confirm your mental maths to the calculator. Take the time to do that. You haven't got to rush. So the next thing I'm going to do is I'm going to split this linear term here according to these two numbers. The 3t squared remains the same. I'm going to put the minus 3 with the 3, minus 3t, and the minus 5 with the positive 5, minus 5t. So I've split that term into two parts. The minus 8t has been split there, and the constant, the 5, is just the same, and it's still all equal to 0. So hopefully you can see that I have split this term into two parts. The next thing I'm going to do is I'm going to factorize the first two terms by looking at what I can factorize out, and 3t will come out as a common factor, leaving me with t from the first one, because 3t times t is 3t squared, and minus 3t divided by 3t is minus 1. And now I'm going to factorize the second pair of terms, including the fact that that's negative. Now if I want to take out, I could take out 5 here, or I could take out minus 5. To decide which, I'm going to look at what I'm aiming for. I know this bracket should match what I get for the second one. So I need to divide by minus 5. So I'll take minus 5 out, leaving me with just t. And 5 divided by minus 5 is minus 1. And that's still all equal to 0. Now, for my final pair of brackets, I can take the matching brackets, the t minus 1, as one of those. And the 3t minus 5 is my other bracket. And there I factorized it. That's something I wanted to do. I've done that. Next up, I need to take these factors, since they're multiplied together to give me 0, either one of them could be 0. So let's say t minus 1 equals 0, then t would equal 1 by adding 1 to both sides. Or if 3t minus 5 equaled 0, then 3t would equal 5, and t would equal 5 over 3. And since we're working to be engineers, let's give that as a decimal. On the calculator, that would give me 1.6 recurring, not 1.6. There's a whole string of 6's afterwards, so that would actually round to 1.7 if I was going to round it. But these are my two answers. T is 1 and t is 1.6 recurring. 1 second, 1.6 recurring seconds. And those are my two answers. And of course, if I wanted to, I could use the calculator to check this, and I would get those answers out using the equation solver tool. Question 3. The diagram shows an example of a fully enclosed steel storage silo with a base. So they're really emphasizing the fact that the bottom of this counts. Fully enclosed means it's got no gaps or holes, and it's got a base. They're saying the whole thing is kind of on all surfaces. It's not got an open face, anything like that. Calculate the total surface area of the steel storage silo. So we want to work out the surface area. I guess that's why the fully enclosed and base is so relevant, because they'll count as part of the surface area. Thinking about this though, we've got this hemisphere on top of what we can only assume is a cylinder. We can assume it's a cylinder because we're given a diameter here, that symbol meaning that this is a diameter that, if you viewed it from above, would be circular. So, the hemisphere, the half sphere here, connected to the cylinder, that join between them is not going to have sort of like a floor or a surface in it. There's going to be it's going to be continuous in between them. So effectively, if we worked out the surface area of this cylinder, we'd need to ignore the circle that we would get on top. And if we were working out the hemisphere, if we had that flat circular base of the hemisphere, we'd ignore that as well, because these two join together seamlessly. So let's go about working this out. The first thing is, for the cylinder, we have a formula in the formula sheet for the total surface area of 2 pi RH plus 2 pi r squared. But this 2 pi r squared, you might recognise pi r squared as being the area of a circle. And the two of them is for the bottom and the top. So I'm going to ignore the fact that there's two of them and just take one of them, because I don't want a non-existent and internal circle. That's not part of the surface area. The surface area is on the surface, the outside. So that's going to give me the cylinder's total surface area. Next, I want to get the hemisphere. Now the hemisphere is going to be half the total surface area of a sphere. So I want to get half and times it by the surface area for a sphere. And in the formula book, we're given that as 4 pi r squared. Well, we can simplify this to being 2 pi r squared, because half of 4 is 2. So if we get the hemisphere, that's going to be 2 pi r squared, and the cylindrical part, 2 pi RH plus pi r squared, and add those two together, that will give us the total surface area. Let's check that we've got all the variables we need. Do we have the radius? No, we've got the diameter. So let's half that. Radius equals 4.6 divided by 2, which with the calculator or your head is 2.3. Okay, so we've got the radius. Now h, the height. A quick glance might lead you to believe that this is the height. It certainly looks like one. But this is the height of the whole object. And this h here, that refers to the height of the cylinder. That's quite a subtle distinction that I can imagine several people might have missed. So how do we work out that height? Well, clearly we need to subtract this height from 7. But what is that height? Well, given that this is a hemisphere, we can think about its radius. Its radius from the centre to any point around the outside will be equal. So if we consider the radius of the cylinder at the bottom, that was 2.3, up the top here, where the cylinder and the hemisphere meet, the radius will be the same. So the radius must be 2.3. Why does that help us here? Well, because the radius is also the same in whatever direction, so straight up and down. So that's 2.3, and remember we're doing 7 minus 2.3, so we can say the height equals 7 minus 2.3, which is going to be 4.7. I'm going to put meters in there now, not because I need it for my working, just in case I forget it later on, as a little reminder. Okay, so that's pi is a constant, r is the radius, we found that, h is the height of the cylinder, we found that. Everything else is now just crunching the numbers and adding it together, so let's get on with it. So the cylinder equals 2 pi times 2.3 times 4.7. Let's just double check. Yep, that's right. Plus pi times 2.3 squared. Time for the calculator. Two pi times 2.3 times 4.7 plus pi times 2.3 squared. Let's just check that we've typed that in as we've written it on our page. Pi times 2.3 squared, pi times 2.3 squared, and use the arrow keys to come back. 2.3 times 4.7 and 2 pi times that. 2 pi, 2.3, 4.7. Yep, that's all good. And that gives me 84.54. And since that's a surface area, I'm just going to put meters squared on there. Again, not required at this stage of my working, but it's a good reminder to make sure I don't accidentally put meters or meters cubed later when I give my final answer. Just keeping track of all my thoughts. So next up, we've got the hemisphere. And that's going to be 2 times pi times the radius of 2.3 squared. And once again, turning to the calculator, 2 pi times 2.3 squared, 2 pi times 2.3 squared. It's such an easy thing to type something into the calculator slightly wrong, to miss-hit a key or something, to lose a mark. It doesn't take long just to quickly double check your work. This 238, I'm going to round that to 24. So that's my cylinder's surface area, and that's my hemisphere's surface area. This cylinder is counting the base, but it's not counting the non-existent internal circle on top, because there isn't one. So I've amended that in my formula. So these are the correct values. I need to add them together. $84.54 plus 33.24. 117.78. Okay, and that will be in meters squared, because adding 2 squared units together doesn't change it to cubed or anything like that. So let's put that down on the answer line. 117.78 meters squared to 2 decimal places. And that's our final answer. Question 4, the last question in section A. An electronic engineering technician has been asked to determine the signal-to-noise ratio value of a signal generator. 4 signal generators have been tested, and the results of the tests can be represented by 2 log 3 plus log 4 equals log A plus 4 log 2. Solve the equation to find the value of A. Show evidence of the use of log laws in your answer. That will be essential. Okay, so let's have a little look at what we've got. 2 log 3 plus log 4. There's no base shown in these logs. And there's 2 ways you can approach that. The first way is when there's no base shown, it's base 10. That's the convention. You don't bother showing the base when it's 10. We normally work in 10 all the time. Base 10, our number system's in base 10, so we don't bother showing when it is in base 10 because that's the standard assumption. However, in this question, I'm not going to evaluate any of these. To do so would mean that I wouldn't have the chance to use the log laws. That's what I'm going to focus on. And the first log law is I know that this coefficient of 2 can go up on top there as a power. So I'm going to rewrite log 3 squared plus log 4 equals log A plus, and I'm going to do that 4 up on top as a power here. A common mistake is people love powers of 2, or rather they have the power to be a 2. They like, oh, it's squared, I'll put the 2 up top, and they end up with 4 to the power 2 instead of 2 to the power 4. Don't get mixed up because you're more used to seeing squared than you are to seeing a power of 4. It's a small thing, but it can happen. Next, I'm going to just evaluate this part here. And that's going to give me log 9 plus log 4 equals log A plus log 16. I know that 2 to the 4 is 16, but feel free to use your calculator when you're working that sort of thing out. One little side note here, and it's one of my pet hates as a teacher. For some reason, people's 9s and their 4s sometimes look completely the same. And that doesn't really work as a means of writing, so just make sure your handwriting's clear with 9s and 4s. Okay, so the next thing I'm going to do is I'm going to use my second log law, which is that I've got these 2 logs being added together. Well, that means that I need to times them. And over here, these 2 are also being added together, So I'm going to times them as well. And that gives me and if log of 36 equals log of 16a, then 36 will equal 16a. And a will equal 36 divided by 16, which is, on the calculator, 2.25. So our answer is 2.25. Before we move on, let's just have a quick look. We're not given any units, so we cannot give units in our answer. There is no need to round because it was a terminating decimal. And that's the end of question 4.